Okay, for what we have for this section 1.3 simulation, okay, we have for this particular exercise, okay, it says to state whether each of the graphs will represent a function. Okay, so we have for graph number 1, if we look at the vertical line test, okay, and if you were to envision running a vertical line, okay, so far we're good for this point, that one, that one, that one, but if you were to run a vertical line through x is equal to 5, you would have intersection at 2 points, and if you exceed intersection at more than 1 point for the same x, it is not going to be a function. And we have for graph number 2, so we have this is good, that is good, and that is good. So graph number 2 is a case of a function. Now for graph number 3, okay, we have to the right this particular point, and we have intersection at 2 points for each x value that we have to follow and going out to the right. So this is not a function. And we have next, okay, if I were to run a vertical line, okay, through this parabola in graph number 4, okay, so this will be a function. And if I run a vertical line, okay, we have here, we have the trouble spot in this particular region, okay, and so this is not a function. And this particular diamond here, everything between x equals -1 and x equals +1, you're going to have intersection at more than 1 point. Okay, so this is not a function. So we have in checking out, and that is correct. And what we have for the next function, or the next problem, okay, we have h of x defined as follows. And it says to find all values of x that are not in the domain of h. And so for h, okay, that which will not be in the domain of this function will be those values that will make x squared plus 7x minus 8 equal to 0. So we have, again, for the restrictions, okay, we have that the denominator cannot be 0. And so for x squared plus 7x minus 8, if I look at factoring, okay, so we have x plus 8 and x minus 1 as the factors. And if x squared plus 7x minus 8 cannot be 0, then neither factor can be equal to 0 either. So we have for the values of x that are not allowed, okay, if x plus 8 cannot be 0, well, we have that x cannot be -8. If x minus 1 cannot be 0, well, we have that x cannot be at 1. So we'll have with our exclusions, so we have -8 and 1 and checking, and that result is correct. For what we have in the third item, it says the functions f and g are defined as follows. Here we have f of x is equal to x squared over x plus 3. And we have that g of x is equal to x minus 5 all over x squared minus 25. Now for the domain of f, now the restriction is that x plus 3 cannot be 0. So x cannot be at -3. And if we use interval notation, so you'll have starting out with those values of x that will be less than -3. And after that, we will have those values of x that will be greater than -3. So we have for the interval notation, okay, we have going past -3 on out to infinity. And as for what we have for the domain of g, okay, now x squared minus 25 would be x plus 5 times x minus 5, and x squared minus 25 cannot be 0, and neither factor can be 0. So if x plus 5 cannot be 0, x cannot be -5. If x minus 5 cannot be 0, x cannot be 5. So we're going to have a couple of exclusions from the domain. So we have, with the smallest set, we have those values of x that will be less than -5. And we have next, we have those values of x that will be greater than -5 and less than 5. And we still have in continuing, we're going to have for the rest of the set, you have those values of x that will be greater than 5. And so this will complete out what we have for the domains of f of x and g of x. And checking, and the result is correct. Okay, for what we have for the radical function, we had the f of x is equal to the square root of x minus 5. And in this one, because we are dealing with an even root radical, okay, so x minus 5, okay, this expression we have inside the radical cannot be negative. And so we have the x minus 5 can be 0, and it can be positive. And we have x minus 5 to be greater than or equal to 0. And the inequality that defines the domain will be those values of x greater than or equal to 5. And so we have for the domain in interval notation, so we have going from 5 and including 5 on out to infinity. And so just taking what we have here, and we have in writing, so we have going from 5 and approaching infinity, checking the result, and that is correct. For what we have the next item, okay, we have another radical function. We have f of x is equal to the square root of negative x plus 8. And since we have a square root, okay, so we have that negative x plus 8 cannot result as a negative quantity. And so if I were to set up what I have here as an inequality, so you have negative x plus 8, it can be equal to 0 and it can be positive. And if I look at isolating, okay, so we have negative x is going to be greater than or equal to negative 8. And again, if I change the signs, since I'm looking at solving for x, remember, if you multiply or divide by a negative, the direction of the inequality changes. And here we have what is going to be the x is less than or equal to 8. And we would have for the domain, so we have going from negative infinity, approaching, and including 8. So just taking what we have here. So again, we have going from negative infinity to 8 and checking the result, and that is correct. Okay, for what we have in this problem, a railroad crew can lay 5 miles of track each day. They need to lay 135 miles of track, and the length L in miles that is left to lay after D number of days is given by the following function, whereupon we have L of D is equal to 135 minus 5D. And we have part A is asking how many miles of track does the crew have left to lay after 17 days. Okay, so we have in this one, so we have L of D is equal to 135 minus 5D. And if we have that D is equal to 17, so we have L of 17, that is 17 days. What we're going to have left over, we have 135 minus 5 times 17, and we have 135 minus, and we have 5 times 17 is 85, so 135 minus 85, okay, so this will be at 50, so for part A, okay, there are going to be 50 miles remaining, and in terms of how many days it would take the crew to lay all the track. So in this particular case, alright, so for what we have here, okay, L represents what is left. So in terms of the number of days, okay, so for L of D, if there's nothing left, in other words, to complete the job, we have L of D equal to 0, and 0 is equal to 135 minus 5D. And in the determination of the total number of days, so if I get D by itself, so I can move 135 over, and so for what we will have here, 0 minus 135 is a negative 135. We have is equal to negative 5D, and if I divide by negative 5 into negative 135, okay, that would be at 27. So you have 27 days altogether, and checking the result, and it is correct. Okay, for this item we have the graph of a function f is shown below, and it says to find f of -3 and also to find one value of x for which f of x is equal to -2. So we have, again, f of x is a way of saying what we have for y. So you're looking at, for f of -3, you're trying to find out what the y value is whenever x is equal to -3. So when x is -3, the corresponding y value is 4. So f of -3 is equal to 4. And it says one value of x for which f of x is equal to -2. So if we look at where y is going to be at -2, this corresponds to the x value of -1. And checking the results, and that is correct. Okay, now we have here a graph where we have the entire graph itself of the function g is shown in the figure below, and it says to write the domain and range of g using interval notation. Now for the domain, you're looking at the x values. Okay, so you have an open circle above the -4, so -4 is not included, but you have going past this, you have running continuously out to and including x equal to 4. So +4 is included, but -4 is not. All the other values are in between. So you're going to have open at -4, closed at 4. So we're going to go with this particular combination. So we have open at -4 and closed at +4. Now for the range, you're looking at the y values, the minimum y value that we have here. Okay, so if you notice at this endpoint, y value is at -2, -2 is included, and if we go out to the highest location, and this is in reference to what we have with this open circle. Open circle means that not only what we apparently have in x is going to be left out, but also in y. So the minimum we have inclusive of -2 for y, but the maximum you're leaving out +3. So you're looking at going from -2 inclusive to like 2.999, but never getting officially to 3. And so we have for the range, okay, so from the bottom to the top, so we have -2, and then reaching out and not quite including 3, so you have the 3 in the parenthesis, and checking the result, and that is correct. Now we have the entire graph of the function h is shown in the figure below, and it says to write the domain and range of h as intervals or unions of intervals. Okay, so we have for this graph, okay, so h is split up into separate parts here. Okay, now for what we have in x, so we have going past -4, approaching and including -1 for the first part. So if I put what I have here in the interval notation, okay, so we have in this one, so you have going from, but not including -4, approaching and including -1. And then we have for the next portion, so we have in union, and we have close points. Okay, so we go from x equals 2 to x equals 4. Everything else in x is included. So we're going to have inclusion of both 2 and 4 and everything else in between. As for the range, now we have your bottommost y value at -3, and that is included. And if you notice, you have, as you go from -3, you have going up, up, up. Okay, and even though we have this segment or this portion to max out at 1, you still have activity going on in y. So you have starting from -3, you have going up, and there's some activity going on in y until we get to approaching, but not including 5. So you have everything between -3 and 5, including -3, but not including 5. So we have for the range, okay, so you have starting from -3, and again approaching but not including 5, and so checking the results, and that is correct.